Welcome to On-Ramp, on our way to MBA 643. I'm Dr. Danielle Morin, and this is Module 6, Descriptive Statistics, Shape of Distribution. For the last two modules, we've looked at measure of location, measure of dispersion, and now we will look at the shape of our distribution. We will look at outliers. What are they and how do we identify them? We will look at Z-scores. We'll look at the 5-number summary. We'll look at box and whiskers plot, at symmetry, and we'll look at the empirical rule. What is an outlier? Then it could be an observation that is unusually large or unusually small. We have to be careful. An outlier might be a data value that has been incorrectly recorded. Maybe there is an additional 0 that should not have been there. Once it is identified, we should correct them. It could be an observation that does not belong to the population under study. Then once it's identified, we should remove it. But it could also be an unusual data value that has been recorded correctly. This is not a mistake. Then it should remain in the study, even though we find it too big or too small. We will show in this module how to use the Z-score and the box plot to identify possible outliers. So let us introduce what we call the Z-score. The Z-score, easily calculable, is the observation minus the mean divided by the standard deviation. When it is a sample, it's x, the observation, minus x bar divided by s, which is the standard deviation. For population value, it's x, the observation, minus the mean, which is mu, divided by sigma, the population standard deviation. So the Z-score allows us to measure the relative location of a value in the data set. As we can see from its formula, it represents the number of standard deviation. A value x is above or below the mean. This Z-score is often called the standardized value. This Z-score can be used to identify outliers. So this is again the formula for a sample. The larger the absolute value of the Z-score, the farther the data value is from the mean. For example, if I have a Z-score of 2, that means my observation is 2 standard deviation from the mean. If I have a Z-score of 0, how can this Z-score be 0? It means the observation is equal to the mean. It means x is equal to x bar, making the numerator 0. A data point is considered an outlier if its Z-score is less than -3 or greater than +3. If it is a Z-score of 4, yes, it's considered an outlier. Let us apply this. Suppose the mean GMAT score is 550 with a standard deviation of 50. Should we consider a GMAT score of 720 as an outlier? You just got 720 for your GMAT. Should that be considered an outlier? How will we know that? Let us calculate the Z-score that corresponds to 720. So it will be 720 minus the mean 550 divided by the standard deviation 50. We find 3.4. 3.4 is greater than 3. Therefore, yes, that GMAT score of 720 can be considered an outlier. Should it be removed from the sample? Therefore, we have to see, was it a possible value? Yes, it was. But it's so far from the mean that it looked like an outlier. How about a score of 420? Let us again calculate the z-score. 420 minus the mean 550 divided by 50, it gives me minus 2.6. If I put this minus 2.6 in that absolute value, I get 2.6. So this is not greater than 3, therefore it is not an outlier. Let us look now at the 5-number summary. This 5-number summary, important information is gathered within those 5 numbers. It's described the center, the shape, the spread of the data. So the 5 key numbers I should say. The smallest observation, x the smallest. And then the value of the first quartile, Q1. The value of the median, Q2. And the value of the third quartile, Q3. And the maximum, x the largest. Those 5 numbers help me describe the population or the sample I'm dealing with. Let us take our example. The age of 20 randomly selected people who went to see a movie on Sunday afternoon. Derive the 5-number summary. We have already done the calculation. From module 4, we have the smallest value was 12, the first quartile 24, the median 31.5, the third quartile 42.5, and the largest was 58. How can I use that to look at the shape of my distribution? So let us take this 5-number summary and put it in what we will call a box plot. Box plot. There are 5 numbers. The smallest value, first quartile, the median, the third quartile, and the maximum. If I put that with my data, so here's my smallest observation. There are 25% of the data before it reached Q1, another 25% of data before we meet the median, another 25 until Q3, and the right side will be my other 25%. So a box plot is a box that is in the middle where the side of my box correspond to Q1 and correspond to Q3. The box is divided into 2 portions, and that portion in the middle, the line in the middle, is the median. The median is not necessarily in the middle because this is the shape of distribution will be revealed from this. This side here, this box, we call that my box. But these 2 lines that go from the Q1 to the smallest value or from Q3 to the largest value, those are called the whiskers. This is why the box plot is sometimes called the box and whiskers plot. Remember, the box in the middle is defined by Q1 and Q3. Within the box, there is a division, which is the median. On each side of the box, we have the whiskers. And the whiskers will stretch to the smallest and to the largest value. So again, this 5-number summary is represented by the box plot. If the distribution is perfectly symmetrical, the distance from the first quarter to the median is equal to the distance from the median to the third quarter. When it is symmetrical, the line which is in the box is exactly at the center. Also, when the distribution is symmetrical, the distance of the whiskers, the length of the whiskers from the smallest to Q1 here will be the same as the distance from Q3 to the largest. If it is symmetrical, everything will be centered around the mean. The median, not the mean, the median. So the box plot can either be a vertical or horizontal orientation. We like to see it vertical, but Excel gives them to us vertical. It's the same information that is gathered. Let us take our example that we had. We have already calculated the 5-number summary. When I look at my 5-number summary here, it does not give me the shape of my distribution. But when I will build a box plot, I will have a better idea. And this is what Excel will give me. Excel will give me a vertical box plot. So let us see what is given. The line, the smallest line of the box is Q1. The line in the middle of the box is Q2. The top of the box is Q3. Everything. And we have a little X there in the middle. This is not a mistake. This is also given as the mean. This is the mean that we had, X bar 32.45. Therefore, everything is into this box. It is very useful, the box plot is very useful when I want to compare distribution. So I have the age of people who saw the movie on Saturday night, and I have the age of people who saw the movie on Sunday afternoon. And this is the corresponding box plot for Saturday and the one for Sunday. What can be said about that? What is the first thing that we note? I note that the middle 50%, the IQ, the interquartile range, the middle 50% is much bigger for the Saturday night than it is for the Sunday afternoon. The Sunday afternoon, there seem to be less variation in the age group than it is on Saturday. I could compare several distributions this way just with the box plot. I can see with the box plot of the Saturday night, the age variation from 12 to 81 show a very big difference. I see the median and the mean are both bigger for Saturday night, so more variation. So it would be interesting if we have many groups to compare. Now, how can I use the box plot to identify possible outliers? Now, of course, as soon as I identify an outlier, it doesn't mean I will remove it or I will delete it. I have to look. Is it because of an error in recording the number? Then I correct. Is it an observation that does not belong to this study? Then I remove it. But if the observation was properly recorded, then we will study it more deeply. So let's look at how we can do that. To identify possible outlier, I need to build some fences. I need to build fences around this graph. The box in the middle does not change. It is still with sides on Q1 and on Q3. Right? Hinges the sides. And then we have the whiskers. Here is the whisker that we have in green. I have to build what we call the inner fence. Inner fence will be located at 1.5 the interquartile range from the box. Right? We calculate our Q1 and Q3, which we needed to build the box, and we find our interquartile range. And I will find my first fence will be at 1.5 times the interquartile range, smaller than Q1. Here it is. I go on the other side. My other inner fence will be 1.5 times interquartile range away from Q3. These are my internal fence, the inner fence. Anything that is within those inner fence is not considered an outlier. Anything that falls outside will have to be studied. Then we will also introduce what we call the outer fence. the outer fence. They are located at 3 interquartile range. That was 1.5. Now we will move to 3 interquartile range from Q1. Here are in blue my 2 outer fence. Now the decision about identifying outliers will depend on those fences. An observation that falls between the inner and outer fence, somewhere here, this one will be called a mild outlier. We represent it often with a star. If on either side, it could be here or there, an observation that falls outside, completely outside the outer fence, this one will be considered an extreme outlier. Therefore, if I want to identify outliers using the box plot, I create my box plot and then identify the fences, the inner fence and the outer fence. Now, something will change in my representation because the whisker is attached to Q3, the side of the box, but it will end at the last observation that is within the inner fence. All right? It will not stretch all the way to the extreme value. No, it will stop at the last value that is within the inner fence. The observations that are bigger than the inner fence will be identified by star or by a circle as being outliers. Same thing on the other side, on the left-hand side. So my whisker will go from my box to the last value that falls within the inner fence. Anything outside will only be identified with a star or a circle. Let us see in an example what happened. This is the box plot for our cinema attendance. We saw we need to find my interquartile range. 42.5 minus 24, I have 18.5. Let us build my inner fence. The inner fence here, I'll take on 24, this is my 24 here, minus 1.5 the interquartile range, it gives me minus 3.75. Let us build it on the other side. It's the Q3, 42.5 times 1.5 the interquartile range, which is 70.25. So I will draw this in my table, in my box plot graph. This is my inner fence. Is there any value that falls outside the inner fences? There, none of them. So I don't need to plot the outer fence. Nothing is bigger than that. And the whisker will go all the way to the largest value, which is happen to be within the inner fence. So therefore, in this case, we have no outlier. Let us consider again the example for the Sunday afternoon at the movie. But this time we observe a different observation. Somebody gave his ticket to his grandma. So Granny decided to go, and she is 88 years old. It does not impact on the Q1, does not impact on the median and Q3, but it will impact on the value of the largest observation. Let us start that again. My interquartile range did not change. My inner fences are the same, and the outer fence is 24 minus 3 times the interquartile range. 42.5 plus 3 times the interquartile range, 98. So here's my box plot. I have to take my inner fence here. So here it is. My inner fences are here. Those two are my inner fences. And then I will plot my outer fence. It goes all the way to 98, and one is too small. We know we don't have value. So the black lines here are my inner fences. The blue line is my outer fence. Do I have any observation that is outside the inner fence? I have one observation here. So that observation outside the inner fence, but not bigger than the outer fence, it was the 88. So it's between 70 and 98. So this one is a mild outlier, and I don't have any other observation. As we can see, we have the whiskers that ended to the last value that is within the fences, the inner fence. We did not stretch the whisker all the way to the outlier. So we have, because it is between the two fences, it's a mild outlier. If I have somebody who was 110 years old at the movie, then yes, definitely it would be more than the outer limit, outer fence, then it would be an extreme outlier. All right, so the box plot in itself helped me understand the value of helped me understand the shape of my distribution, but it also helps me identify outliers, and that will be very useful all the way through the course. So if we recall what we have, in the case of a box plot of that sort, I see that the middle, this is the median. The median is not well centered. There's more distance on the left side. Then we say the distribution is left skewed. When it's bigger on the left, we said it's left skewed. I can see that here. It means we had small values, more small values, and it was the mean, x bar, has been pulled toward the small value. In this case, the mean is less than Q2, less than the median. If on the other side here, we have more distance on the right, that means the mean will be affected by the large value, therefore my mean will be greater than Q2. I can see that with the whiskers, longer whiskers, and the distance in the box from the median to Q3 is also bigger. Then we call that right skewed. If everything is all well maintained, good symmetry, then we say the distribution is symmetric and x bar is equal to Q2. So if it's skewed to the right, the mean is bigger than the median. If it's skewed to the left, the mean is less than the median. So this one is important. So that's one way of looking at the shape of the distribution. Compare the mean with the median, and that is always a very good indicator. Let us bring our data in Excel and try to reproduce the box plot. So I will identify all these observations here, and I will insert, and I go to recommended graph. Sometimes it will give me what I need, but it's not there. Then I'll use all chart. In the list provided, I see box and whisker. That looks like what I need. All right, so here's my box plot. I might like to add the titles. So the X title, so here we have, this one will be my attendance. This will be the ages. And I will like to see also data labels. We have here, I see the 24, 31, and 0.5 and 42.5, and this little x in the middle will be our mean. So if we format the data, we see everything that we need. We don't have to change the gap. Everything is well positioned. We can have the legend here, which will give me that it is the first series. Not very useful. The chart title, it was the box plot of attendance. All right. So do we have any outliers? So we don't, because if there was an outlier, the Excel will give it to us, will show us without identifying the fences, but it will show us where is the possible outlier. Let us now reproduce the box plot when Granny decided to attend. All my data is in this column, so we'll have this one, and we will insert recommended chart, and we saw that it's not there, so we go to the box and whisker plot. And now I can see that the box plot identifies an outlier. It does not tell me if it is a major outlier or not, but it identifies it as an outlier, and this is where I will have to work with this. The axis again in this chart, it would be my attendance with Granny. The attendance with Granny. Here, the other axis will be the ages. The chart title will be my box plot. It's very important to label our graph. So it will be the box plot of attendance when Granny is with us. And from that also we saw that we can put the data label. So each of the line, that is the maximum value that is within the inner fence. We don't see the inner fence, but we see it is within the inner fence, but the outlier is outside. The outlier has been well identified. So basically the box plot gives me the information that I need, the shape of the distribution, and it also shows me what could be possibly the outlier in this setting. Of course, we can change the colors, we can change everything, but the fact is that this distribution has an outlier. Will it be easier to see in this? Not really, but different ways of identifying and coloring and presenting the information. When I go to now a new rule, the empirical rule. When the distribution of data exhibit a symmetric bell-shaped distribution, for those who took some statistics before, we don't mean the normal distribution, but something that looks symmetric and bell-shaped, the empirical rule can be used to determine the percentage of data values that are within a specified number of standard deviation from the mean. So whether I am 1 standard deviation, 2 or 3 from the mean. This is what looks like a symmetric bell-shaped curve. The summary is this. Within 1 standard deviation from the mean, we have 68%. That means I take the mean plus 1 standard deviation on one side or minus 1 standard deviation on the other side. So the interpretation is 68% of the observation are within 1 standard deviation from the mean. 95% of the observation are within 2 standard deviations from the mean. And if I have 3, 99.7% of the observation are within 3 standard deviations from the mean. So I can see there's not much left beyond the 3 standard deviation. This is an important information. Let us apply that here. Suppose the GMAT scores have a bell-shaped distribution with a mean score of approximately 550 and a standard deviation of 50. What can be said about the distribution of results? Well, if I go from before, I know that 68% of the results are within 1 standard deviation from the mean. So within 1, that means the mean is 550 minus 50 to 550 plus 50 plus 1 standard deviation. It gives me 500 to 600. The rule says again, 95% of the results are between 450 and 650. Why? It is 550 minus 2 standard deviation. 1 standard deviation is 50. 550 plus 2 standard deviations, it gives me 450 to 650. And the rule also tells me that within 3 standard deviations, so it is 550 minus 3 standard deviation and 550 plus 3 standard deviation. Then it's 400 to 700. I can look at the last one here. It says that the GMAT, a score of 650 would be exceeded by what portion of students? Let us see that. We have 650 is what we found this number here. So let us use this information. 95% of GMAT are between 450 and 650. So the distribution is a bell-shaped, symmetrical. 95% of the observations are here. On each, if 95% is there, what is left for each little portion on the side? 5% divided by 2, so I have 2.5% and 2.5%. What can we say about a GMAT score of 650? A GMAT score of 650 will only be exceeded by 2.5% of students. So the empirical rule can be used to make some approximations about positions. The Z-score can be used to identify outlier, and the Boxplot also can be used to identify possible outliers. We will see in the future many more ways of deriving this. Now this is time for a review test, so I hope you enjoy it and see you next time.